So in this video, we have the height of a particle, h meters, at time t seconds, is given by this. Now, this will look somewhat unfamiliar in its layout. So what you're seeing here is what's referred to as a piecewise function. And what we mean by that is that it is made up of several pieces. So in this situation, in this case, it is made up of two pieces, one where h is equal to 4, and it's equal to 4 for the first 2 seconds. And then it's equal to 2t squared take away 4 for the next 3 seconds. So it starts off as a straight line, horizontal line, and then becomes a parabola. Okay, so the first thing that we need to do is sketch the graph of the height of the particle in the first 5 seconds. So let's draw some axes, and so we can visualize what's going on here. Okay, so we'll have this as h, and this is t. So we're starting off at 4 meters high for the first 2 seconds. So we want to draw a horizontal line, and that is the first 2 seconds. So that's at 4. Then it becomes a parabola for the remaining 3 seconds. Now, what you want to do is you want to make sure of where the start point is, or the height at when t is equal to 2. So substitute t is equal to 2 into this. So 2 squared, 2 times 2 squared is going to be 8. Take away 4 is 4. So we know that it's actually joining up here. Okay, so that's good. Sometimes that might not be the case. So you can have scenarios where the particle essentially jumps. So you could have the particle is suddenly at this point here, okay, rather than being at that point at that time. That can happen. Obviously, it's not a physical scenario if that's the case, but you can have a piecewise function that doesn't completely join up. So, from then on, it must look like a parabola. Okay? So, it must look something like this. And at that highest point, we must now be at 5 seconds. Okay, and so we probably want to figure out what that highest height is. So that's when t is 5. So 2 lots of 5 squared. Well, 5 squared is 25. 2 lots, that's 50. Take away 4 is 46. So this would be at 46 meters. So part B, find the length of time that the particle is higher than 5 meters. So there's going to be a point here where we're at 5 meters, and this is the length of time that we're going to be above 5 meters. Okay, so for that particle there, that part of the trajectory. So we need to work out when it's at 5. So I need to put this 2t squared take away 4 equal to 5, and then solve that equation. So if I add 4 to both sides, and then divide both sides by 2, so 9 halves, or 4.5, and then I need to square root both sides. Now, in square rooting, we get this plus minus, but we don't have negative time here. We're only interested in positive time, so this will be the positive square root of 9 halves. I'll work out what that is on the calculator in a moment. So this point here is the square root of 9 halves. So the time that I am interested in is from 5, or from square root 9 halves to 5. So that gap there can be found by doing 5 take away the square root of 9 halves. So The square root of 9 halves is 2.1213. So if I subtract that from 5, we get an exact answer. So the calculator is giving me 10 take away 3 root 2 over 2. Let's put that as a decimal. So that's 2.87867. So to 3 significant figures, that would be 2.88, and we're in time, so that's in seconds, to 3 significant figures. And we're done.